All right, so let me go over some of the solutions for this test for you guys. Hope everyone had a nice break. So 4 main questions. The first question was basically about a hierarchy. And so the hierarchy here is similar to one we talked about in class for one of the examples. And so I was hoping that would get you guys a starting point here. And you can see that I have a hierarchy of trees. So at the highest level I have trees, right? For this case, pine inherits from trees, maple inherits from trees, and crepe myrtle also inherits from trees. So basically the hierarchy looks something like this. And for crepe myrtle, I'm just going to put CM for short. Right? And so in this, it says, please insert code below that is requested in the comments. So the first thing it says, instantiate a single vector called forest that can be used to hold pine objects, maple objects, crepe myrtle objects. Okay. And so here's kind of the interesting thing, right? There's 3 different types of objects, but I have one vector that does that. It says initialize the size so that you can hold 142 trees made up of a combination of these 3 types. Please read part B in the next page to guide you in your decisions. Well, really what we want to have here is we'd like to have a vector for this case. Actually, let me pointer. I think that's what I want. So we'd like to have a pointer, and my pencil here is a little weird. It's a pencil, isn't it? So let's go to pen. So we'd like to have a vector, basically, that holds these, and so the idea is that we'd like to have our polymorphic data structure that we talked about. And so I'm going to have a vector, basically, right? And it can't be trees. If you put trees only, then you lost 5 points for that. Really what I was looking for is, for this case, is I wanted a vector of tree pointers, okay? Tree pointers, and I wanted you to call it forest. And I wanted you to initialize it with 142 items, okay, for this case. So that was it. Now you have your vector of tree pointers that you can start to manipulate. Now it says use a random number generator. Don't worry about the C to populate the vector for us. Put 142 trees in random types. Please allocate these trees in the heap. Please use a vector iterator to perform this task. So a couple of different things that I was looking for here. So maybe what I will do is I'm going to make the vector iterator first. So we have a vector trees, okay, and it's going to be iterator, and I'll just call it IT for short. Okay, then what I'm going to do is I'm going to go through a for loop, and so where IT is equal to, I'm going to use the member function begin, which returns an iterator to the beginning of the list. If IT is strictly less than the end, all right, and then I'll use some iterator arithmetic. Okay. Then what I'm going to do is maybe I'll do int. I'll just call it type, and I'm going to set this equal to rand. I'm not going to worry about the seed as it indicated in the problem. Rand mod 3. So this will basically give me 0, 1, or 2. I'm going to use a switch statement, actually. So we have switch type, okay, and then I'm going to have case 0. I will assume this is going to be a pine. So what we'll need to do here is we'll need to dereference the iterator. That points to the element, right, for this case. And that's going to equal to new. I have to allocate in the heap, pine. And I'm going to put a break statement here so it doesn't fall through. I have case 1, again the iterator, and that's a pointer, right? This returns a pointer. You lost some points if there was a mismatch between these two. Maple. And then break. And then case 2 is going to be new crepe myrtle. And then I'll have a break there. don't need one necessarily. And then I'll do my switch, and then I'll be done. Okay? So that'll go through, generate the random number, associate the new, allocate it in the, because basically, right, we have an array of these pointers, and so it's going to go through, and sometimes it's going to be maybe a pine, sometimes it might be another pine, sometimes it might be a maple, okay? And so this structure allows me to do that. It says, now add code to make sure that there are no memory leaks. Please use a range-based loop to traverse the vector. So this is the third type of for loop that we were talking about when we talked about the standard template library. And so here what I'm going to do is I'm going to have for, and I'm going to declare the element, right, for this. So as I look at this, this is going to be called forest, right? This is the vector that I'm traversing. And so in this, I would like to have a pointer. It is an array of pointers, or vector of pointers. And so I'll just say, whatever, I'll call it current value. Okay? And so then what I'm going to do, I could check for null here, but I'm not going to do that for this case. I'm just going to go ahead and delete it. All right? So I'm going to delete, and this is expecting a pointer at this point, right? And so this cur, right, for this is a pointer, is the pointer basically to the element, and so I can just delete cur. Okay. Now there is an issue which I didn't take off for. I was going to take off 5 points. It was kind of my tricky problem. And here I'm deleting through a tree pointer. Okay, so deleting through a base pointer. Basically, I'll say sometimes requires a virtual destructor. Okay, such that, and we did this in class where we noticed that it only calls the destructor for the base class. But if we make it virtual, then it'll call the destructor associated with the derived class. So just be aware of this. If you look on your paper, it's like no virtual destructor. A few people got it, and I think I gave them a little bonus points for that. And I did not count off for that. It's boosted everyone's grade a little bit by about 5 points in that regards. Okay. All right, next problem. So this is a trace through problem for this case. And so for the trace through, it's very, very, very similar to one of the practice problems that I given to you guys. So I was hoping it wouldn't be too difficult. So we have our A class right there, right, for this case. We have some static data right there. And, of course, we have to initialize it right there in the global namespace, like we've been talked about. So it's initialized to 10. So I have data. So there's 2 different objects, basically, that I'm going to instantiate, but one piece of static data. Right? That's what I wanted people to understand when we talked about this. So it's static data plus is initialized to 10. Okay? So as we start to go through, and there's a function call here, notice the call by value. So a copy constructor is called. Here I didn't provide a copy constructor, so just the default one is called. We'll talk about that in a second. Okay, so the first thing is I come to main, and I instantiate the first object. Okay, so if I look at the constructor up here, the constructor that I have with one argument is right there. Maybe right there? Yeah, right there. And so, so basically it's going to initialize data A, and it prints out a little something, constructor with the data A element. And so that first constructor call is basically I'm going to call the constructor. So it's constructor space, and then it's 91, because that's the data that's associated with that one. Then I do another constructor call. And so here it's constructor 5 for this case. Then we do, now we do the function call. It's a global function. It's a call by value, so copy is made. So copy constructor is called, but I'm using the default one, so you're not going to really see it print out anything in this regard. So here it says in function, so it'll print out, just going to move it over here so I can see it, in function with, and then a object get a data. Well, the get a data is 91, right, because it's object 1 for this case. end of line. Then it goes through here actually, and it starts to take the A object, and the indexing operator is overloaded. So right there, it's overloaded, and it basically just returns the elements of the array. Okay, so this actually has a kind of a static array right inside of it, and the array size is a constant up here, which is 3. Okay, for this case. And what this does is, and this is a little bit of what I was trying to test you on. In a call by value here, if I have a static array element inside, it does a deep copy. So here I'm dealing with the copy. Okay, so I'm dealing with the copy, not the original object 1. So dealing with a copy. So yeah, I've initialized, or I've changed every value of the static array in the copy to -1, but it hasn't changed the value that I actually have initially. And you say, well, what's in that value initially? Well, it's in the constructor here. Right? And so in the constructor, it actually goes through and it creates this array, and every element is equal to 42. Right? And so that's important. That'll be important here in just a minute. Right? Now, the one thing here, when it does, because it made a copy, after this, the destructor is called. Okay, so the destructor is called for this case. And there is a destructor here. And so it just says destructor. What does it print here? It's a destructor. Maybe it looks like a little space there. It says data A, it's a 91. Okay, and so that copy is destroyed. So then we do that. Oh, sorry, we haven't done that yet. So we just did the destructor. Then we go on to object 2, increment A+. So if we come up here to increment A+, this is actually the static data. Okay, and so this data is now incremented to 11 through object 2. I do object 1, print data. Well, print data prints out the data, and then it prints out the static data, and then it prints out its regular data. So in this case, the static data is now 11, and the regular data is still 91. Okay, and then finally we print out, for object 1, we print out all its elements. Okay, and so what you realize, this is a call by value. Okay, and so this did not change object 1. Okay, for this case. And so here, if I come through here, for object 1, then this is going to print 42, end of line, 42, end of line, 42, end of line. All right. Once it's done, we call the destructors, and as we talked about in class, the destructors are called in opposite order. So here I'm going to have destructor 5, right, because that was the last one called, and then destructor 91. Okay, and that's it. Here's your answer. All right, well, let's keep going. Another trace through. Again, very, very similar to what we had in class. Very similar to what we had in class. Well, I should say also in the example problems that I gave to you. So make sure that you use those. So here I have, let me get the lay of the land. Here's the base, maybe appropriately named base. Here's sub 1, which inherits from base. Here's sub 2, which inherits directly from base. And here's sub 3, which inherits from base. I'm sorry, it inherits from sub 1. I said it wrong. I drew it correctly. Right? So sub 3 is inheriting from sub 1. So there's our hierarchy, so that we can see it visually. Then what I'm going to go through, and here I'm going to call the global function with a sub 1 object and a sub 2 object, and then we'll just directly call function 3 here, okay, for this case. Now, here's the deal. For this function, I'm passing it as a base reference, okay? And so if I do that, now I have to deal with virtual functions. If I didn't have any virtual functions, I would only get base functionality. But if I have virtual functions, then I can get the derived class functionality for this case. And it looks like for this, it calls 1, 2, and 3. Okay? So let's do this for a base reference to a sub 1 object. Okay? So we're calling function 1. Well, function 1 is pure virtual here. Okay? So I come and I say, well, does sub1 have a function 1? It does. And so it should say, hello from sub1 function 1. Okay. Then we call sub2. Is it virtual? Yeah, it's pure virtual. Does sub1 have a function 2? It does. So it says hello from sub1 function 2. Then we call function 3. Function 3 is not virtual, so I'm going to get base functionality. And so class base has a function 3 that says hello from base function 3. So we have hello from base function 3. And then I'm done with the function. Now I call the function with S2. With S2, basically, now I'm going to call function 1. Again, it's virtual. Sub2 has its own function 1. And so it says hello from sub2 function 1. Hello from sub2 function 1. And then we call function 2. Hello from sub2 function 2. Right? It's called this one. Right? We're going to get derived class functionality because these are both over here. They're both virtual functions. And then finally, sub3 function 3. Well, again, it's not virtual. So it's going to say hello from base function 3. All right, and then we're done. We're done with this. We come down here. We've done this one. We've done this one. Now, last one is just to call sub3 function 3. Now, again, we're not handling it through a base pointer or a base reference. We're handling it through its name. Right, we're handling it through its name. And so I should get derived class functionality. Well, sub3 doesn't have a function 2, or function 3. But it inherits a function 3 from sub1. So it'll say hello from sub1 function 3. Okay. And then that's it. Last problem. It says, please provide code for the following based on Appendix A. And so Appendix A basically has a time class. So it's hours, minutes, and seconds. And it looks like we have setters and we have getters. We have a print function. And we have a constructor for this. So the problem one says this. Although the compiler would make a copy of the constructor for the time class in Appendix A, I would like for you to show me a copy constructor implementation for the time class in Appendix A that would do the same thing. Okay? So basically I want you to make a copy constructor. And so I'll assume it's outside the class interface. Implementation here. It's a constructor, so it has the same name. For a copy constructor, it's looking for a constant time reference. And so this is, I'll say, to copy. Okay. I could have used an initializer list here. Maybe for kicks, what I'll do is I will just show it out. So here is hour is equal to toCopy dot hour. Could have used a set. Didn't in this case. If you did, that was fine. In fact, maybe preferable. Minute. And here's second. And so all I'm doing is what I'm creating here. Basically, I'm copying over. If you want to do explicit this, you could do that as well. It's not required by the compiler. Some people try to return something here. It's a constructor, so it doesn't return anything. Right? The second one is, although the compiler would like to make an assignment operator for the time class in Appendix A, I would like for you to show an assignment operator implementation for the time class in Appendix A that would do the same thing. Please have your operator return a constant reference to a time object. Okay, so now we're going to overload the assignment operator, and I return a constant reference. So if I return a constant reference to this time, okay, I'll assume it's in the time class there outside the interface. So here I'm going to use operator, and there's the assignment, which is just the equal for this case. And then I'm going to pass to it. I could do different things. Maybe I'll pass to it a constant time reference, and I'll call it maybe right-hand side. Okay. So typically, if you look at this, sometimes it's nice to do is it self-assignment, just to make it a little bit more efficient. So if this is not equal to the ampersand right-hand side, so here I'm comparing addresses. If it has the same address, I'm assuming it's the same object. But if it's not, then we need to do the assignment, and it actually looks very similar to what we had in the copy constructor. So here it's right-hand side dot hour. Again, I could have used the set if I wanted to. Right-hand side dot minute. Okay, so there I've actually done the assignment. Some people may look at temporary variable and copy it and return the temporary variable, and that's not good. Okay, here what I'm going to do is I'm going to return a reference to the left-hand side for this case. Typically is what we would do. That's how I'm using it at this point. All right, so that was it. I was hoping it wasn't too bad. I think our average was maybe about a 77 for this particular quiz. All right. Look forward to seeing you guys at the final.